Next thing.
2 weeks. Those things are dead.
Yeah, and look at that. The
So
ballistic
I
scale is
added a couple of
melted. That
slides,
must have got
and
so hot in.
you might want to just write these down if they weren't on your slides that you have if you printed those out. Um, this one is an inequality, so you can't just solve it. You've got to find like you find your zeros. Basically, you find your x-intercepts. And I'm going to have to apologize in advance because I left my good stylus. So I'm having to use these not so good ones to teach today. So the first thing you want to do is factor, and let's see what the x-intercepts would be. So this one factors into x minus 7 and x plus 5, because we know we want to multiply to get negative 35, and then those middle terms have to add to give us negative 2x. And so what I'm going to do is use these over to the side and find what the zeros would be if it was an equation. So x equals 7 is 1. And x equals negative 5 is the other. So what we did was we looked at a number line, and we put a negative 5 here and a 7 here. And we found some test points on each interval to see which one gave us true values. So to the left of negative 5, the easiest one to put in is negative 6. Now, if you'll go back to the factored form, and I was in a little bit of a hurry the other day, the factored form is easier to figure out because all we want to know is if it's greater than or equal to 0. We just want to know if it's positive. So if we put a negative 6 in and negative 6 here, we get a negative here and we get a negative here. Doesn't matter what the number is. You can go ahead and say negative 13 times negative 1. But the whole point of that is that that's positive. So whatever you're getting here, you're getting a negative here and a negative here. You multiply two negatives, you get a positive. And a positive is greater than or equal to 0. It's greater than 0. So we get a true over here in this interval. And then pick an easy number like 0. 0 is somewhere in between negative 5 and 7. And take your factors and plug in a 0. Sorry, the stylus doesn't do as good as my other. So I get a negative here and I get a positive here. So that gives me a negative. That is not greater than or equal to 0. So in the middle between negative 5 and 7, we get a false. And then pick something to the right of 7. We would pick maybe 8. So I picked negative 6 over here. So let's pick 8 and let's put 8 in. 8 minus 7. I'm just plugging into the factored form. And 8 plus 5. That's positive, that's positive. So the whole thing, when you multiply two positives, is positive. So that is greater than or equal to 0, whereas this one would be less than 0. So we get a true. Now, because we have an equal sign here, we put a bracket, and we shade to the right and we shade to the left because that's where we got a true. So this says if your answer is to be in interval notation, union greater than's always, if it's two different places where it's true, you're always going to get a union between those two. So this would be your answer. When you have two different parts of the graph, you have to use a union to put those together, not an intersection. An intersection is where something crosses each other. So that's just another one of the inequalities. So these were just where I was I was using my test points. You have to use test points on these. If you are on the test and you're taking your test and you're showing me your work and you don't show me test points, you're not going to get any credit, even if you happen to get the right answer. Obviously, the answer is going to be either in between 5 and 7 or on the other side of -5 and 7. If you just guess and get it right, I'm sorry, you're not going to get any credit for the right answer. You have to show me the test points. You have to show me where you picked a number and plugged it in and tested it, whether it's positive or negative, whichever it's supposed to be. So don't think that you're just going to get a 50-50 shot at this problem and get it right, even if you can factor it and get the points. You have got to show me that you are testing points by plugging them in here and seeing if those are greater than or equal to 0. You can get partial credit if you make a mistake, but if you're not showing me your test points and you just write the answer and hope you get it right, you can just go ahead and think about something else because you're not going to get it if you don't show me that you tested those points. All right, now I'm going to do this one, and just because I'm not going to give you, this one's going to give you irrational zeros. So just because I'm not going to give you one on the test, we're going to make that a +3. Because the way I had it, it wouldn't factor, and I was going to do one with not imaginary, but non-rational, irrational zeros. But I'm not going to do that. I'm going to make this a plus so that it will factor. So if I make it a plus, it'll factor and make the problem easier. So this is going to be x minus 3 and x minus 1. So I'm going to come down here lower this time so I can have room to do my test points. So I'm going to put, so x minus 3 equals 0. Add 3 to both sides, you get x equals 3. And x minus 1 equals 0. Add 1 to both sides and you get x equals 1. That tells us where our points are going to be on our number line. 1 and 3. And we want to know if the answers are on the outside of 1 and 3 or in between 1 and 3. So we've got to get a test point. So on this side, I could test 0. In between 1 and 3, I could test 2. And then to the right of 3, I could test 4. So these are my test points. So I'm going to test 0. I'm going to test 2. And I'm going to test 4. Okay. So first I'm going to plug in 0. So that's going to give me a negative times a negative. That's a positive. That's not less than 0. So that's a false. It's not less than 0. So this is false. Now if I test 2, so I test 0, I test 2, I get -1 here, and I get 1 here. Negative times positive is negative. It is less than 0. So I get true here in this interval. And then if I test 4, I'm sorry, this is so sloppy. That's why I'm telling you what I'm doing. So I'm plugging in 4, 4 minus 3, 4 minus 1. Both of those are positive. That is not less than 0. So this is false. So the solutions are between 1 and 3. And I don't have an equal here, so I have to use parentheses, not a bracket, and I shade in between. So my interval notation answer is from 1 to 3. That's the solution to this inequality. It's the interval between 1 and 3. So I know that's messy, but I hope because I talked you through it, you can see what I'm doing. This little messy place right in here in the middle, that's just where I'm testing my numbers on each interval to see if I get true or false when I plug it into the factored form of the equation. Now that's the easy way to do those. Do we have any questions on those? Yes, ma'am, I did because I changed the problem. I changed that to +3 instead of -3 so that it would factor. On the test, I'm not going to give you one that will not factor. No, that's okay. Um, that's just fine, no problem. I changed that to a +3 on purpose because on the test, if I give you an inequality, I'm not going to give you one that won't factor. Okay, so you can watch the video and see what to do if it won't factor. You have to use the quadratic formula to get the zeros. No, you don't have to be sorry. I'm sorry. I was so blunt. I'm just a little blunt sometimes. But I did. I changed it on purpose because on the test I'm going to not give you one that won't factor, so you won't have to spend all that time using the quadratic formula. All right. So section 3.2, zeros of polynomial functions. This is kind of off the beaten path a little bit from what we've been doing, but it is directly related to the things that we've been doing. When you solve a quadratic equation, you're literally finding the zeros. And this section just teaches us how to use synthetic division to break something down and be able to find all of the zeros. So what I mean by zeros is if you are to graph a function, any function at all, and everywhere it touches the x-axis, we get a 0 because these points have a y value that's 0. Whatever the x is called the 0. So all x-intercepts are called zeros. All x-intercepts. Sometimes we won't have an x-intercept, but we'll still have a 0, and that will be called an imaginary 0. It won't cross the x-axis, but it will be an imaginary 0, and it would cross the imaginary axis, but we don't know how to graph in the imaginary plane without having a computer model to do that. So we just have to accept that. So our objectives for this section will be evaluating a polynomial using the remainder theorem, using synthetic division to evaluate a polynomial, determine all possible roots using the rational root theorem, and then finding all real and imaginary roots of a polynomial function. So those are our objectives. So the remainder theorem basically says if R is the remainder when a polynomial is divided by some factor, then the remainder is what the polynomial would be if you plugged it in. Okay, so if you plug in an X value and you get a 0, that's when it's called a 0. If you get a remainder, then that remainder is what you would get if you actually plugged that value C into the polynomial. So first, let's just review if you've not seen synthetic division before. Hopefully you have. I'm going to show you how to do synthetic division. So the first thing that we want to do is we want to bring down our polynomial. And if we're missing a degree, and this starts with 3 and goes to a degree 1, we want to add a 0, x squared in, because we don't want to be missing one of our degrees. And in long division form, it would look like this. And we would just use long division to go through and find that. Well, synthetic division just is a little bit of a shortcut for us. You bring down your coefficients of your each degree. So this is an understood 1, 0, -7, 5. And then I take my factor and I set it equal to 0. And I actually find what that number would be. So I'm subtracting 2, sorry. So x equals -2. So what we're going to do is use -2 as our multiplier. So it's always the opposite sign of whatever this is. So I'm going to bring down the 1. You have to start somewhere. So start by bringing down the 1. And then this multiplier, I'm going to get my next value by multiplying by -2. So I'm multiplying by -2 and bringing it over here. Now I'm going to add. Then I'm going to multiply by -2 again and bring it to the next space over. Then I'm going to add again. Then I'm going to multiply by -2. And that gives me 6. And I'm going to add and I get 11. 11 is the remainder. So I'm going to show you what that factor theorem means, remainder theorem means too in just a second. So what I've got now is I've got a quotient. These numbers here are my new coefficients for my depressed or compressed polynomial. So I have compressed this polynomial into a smaller one. So I started with degree 3. So I'm going to go down by 1. And I'm going to bring down the 1x squared minus 2x minus 3. And then since my remainder is positive, I'm going to put plus 11 back over my divisor. And this is what you would have gotten if you had just used long division on that problem as well. Synthetic division, if you haven't seen it before, is just a shorter, quicker way to do the division problem than having to go through all the steps of long division. Now, what the remainder theorem told us in the previous slide is if we plug in -2 into that polynomial, we should get 11. Let's just see. Let's see if the remainder theorem will work. So that gives us -8 minus 14 plus 5. No, plus 14, I'm sorry. So -8 plus 14, that's 6 plus 5, that's 11. So it does. But to me, using synthetic division to get that answer, that's a whole lot harder than just plugging in the -2 and getting the 11. But that 11 does have a specific um, use. That 11 is what you would get if you actually plugged -2 back in. That's what the remainder theorem tells us. All right. So we're going to be doing plenty of this synthetic division. So if you haven't seen it before and you don't get it yet, just hang on. You're going to get it before it's over. This says use synthetic division to find P of 3. So that's what I just showed you in the last one. If you plug 3 into this polynomial, it should give you whatever your remainder is. Now, that helps us later on because it makes things a little quicker for us. So because it asks us to, let's go ahead and use synthetic division. I'm missing the x term, so I need an x term. I have to put a 0 in. So bring down the coefficients. And the 3 is going to be your multiplier here. So I bring down the 1. Start there, start multiplying. So I'm multiplying by 3. I get 3 and I add, multiply by 3 again. I get 12 and I add, multiply by 3 again, and I get 36 and I add 27 is the remainder. So 27 should be what I get if I plug 3 into that polynomial. So let's check it. So I get 27 plus 9 minus 9 equals 27. I think that's pretty cool. That the remainder you get when you use synthetic division is what you would get if you plug that number into the polynomial. So that can be helpful if you have to use synthetic division anyway. Now, the factor theorem says the number c is a 0 of the polynomial function if and only if x minus c is a factor of the polynomial. So that's why I always set x minus 3 or x minus whatever I get or x plus whatever I get equal to 0 and solve, because that gives me the actual 0. And then the fundamental theorem of algebra says if y equals p of x is a polynomial of positive degree, in other words, you got an x cubed or an x squared or an x, then you have at least 1 0 in the set of complex numbers. Okay, so if it's a positive degree polynomial, then you will get at least 1 0 that's in complex numbers. So sometimes you're going to get complex answers. All right, using the factor theorem to factor a polynomial. Well, this also helps us find the zeros. So if we already know one or determine if x plus 4 is a factor, what we want to do is use synthetic division and see if our remainder is 0. And if it is, then we can try to finish finding the zeros from that point or finish factoring the whole polynomial. So it helps us to be able to break down a higher order polynomial into something that we can factor or we can find the remaining zeros. So I'm not going to do that one because the steps are already done for you. I'll do the next one though. So that's just an example that's already worked out. Is x minus 1 a factor of that polynomial? If it is a factor, then finish factoring completely. So I'm going to use synthetic division here. Zero, I got to have a zero for x squared because I'm missing the zero. I'm missing the x squared term. And what I'm doing is really I'm doing division, but I'm not going to use long division. I'm going to use synthetic division. So I'm going to bring down my coefficients. I'm going to set that factor equal to 0 and solve for x. So it always changes signs of the factor. The 0 is the opposite of what's in the factor. So my factor, my 0 will be 1 if it is a 0. And you can't finish factoring it if it's not a 0. So you want to see if it's a factor. And if it's a factor, then you're going to get a remainder of 0, and you can factor your remaining polynomial that you get. So I bring down my 1, and then I start with my multiplier. Add, multiply again, add, multiply again, add, and my remainder is 0. So that means I've got another polynomial, and I'm going to see after I finish writing this polynomial if I actually can factor it. So that's going to be x squared, because I decreased my degree by 1, plus x minus 2. So I've got one factor already, x minus 1. I know it's a factor because I got a 0 for my remainder. So that means if I multiplied these two things together, I would get this cubic up here. This is what I would get if I actually used a distributive property and multiplied these two things together. I would get this polynomial that I started with. So now I'm going to see if I can finish factoring, and I can, because that's a -2 and a +1. So I can use x plus 2 and x minus 1. So those are all of the factors of that polynomial. Now, we could set those equal to 0, and that would give us the actual zeros of that polynomial. And we're going to be doing that as well. For this lesson, all it asked us to do was factor it. So it didn't ask for the actual zeros. So I'm going to show you how to get the possible rational zeros. The rational zero theorem does not identify, it does not identify the zeros. It only identifies possible zeros, possibilities. So when we're trying to find the zeros of a polynomial function, we're trying to find those x-intercepts, or those basically zeros or solutions to the polynomial. Solving a polynomial function is like solving a quadratic function. You're solving for x by factoring or by using the quadratic formula, but you can only factor and use the quadratic formula if you get it broken down into a quadratic. So we have to start somewhere, and sometimes we don't have a factor given already. So we have to use these possible zeros to identify something we could try to use for a 0. All right, so here's how you find the possible rational zeros. Rational zero theorem, we're going to find the possible rational zeros. So what we're going to do is we're going to list the factors of 6. P is a factor of 6. So we get our P's from here, and we get our Q's from the leading coefficient. Okay, P from the last, from the constant, Q from the leading coefficient. So list all the factors of 6. So we've got 1, 2, 3, and 6. Those are the possible factors of 6. And then list the factors of Q, 1, and 2. So the factors of 6 we know are 1, 2, 3, and 6. The factors of 2 are 1 and 2. The possible rational zeros are positive or negative P over Q. So you take all of your P's, which are these, and you put them over all of your Q's. And it could be plus or minus. So let me put a comma between those. So the factors of 2 are 1 and 2. So I've got to do 1 over all. I've got to do 1 over these 2, 2 over these 2, 3 over these 2, 6 over these 2. So I'm going to do that. So 1 over 1. And all of these are positive or negative. 1 over 2. So that takes care of the first P. Now I've got to do all the 2's over Q. So plus or minus 2 over 1, plus or minus 2 over 2. Then I've got to do all the 3's over the Q. So I've got plus or minus 3 over 1, plus or minus 3 over 2. And now I've got to do the 6's. So I've got plus or minus 6 over 1, plus or minus 6 over 2. So we're going to reduce these and not write repeats. So our P over Q values are plus or minus 1, plus or minus 1/2, plus or minus 2. This is a repeat. That's a comma right there. Plus or minus 3, plus or minus 3 over 2. Plus or minus 6, plus or minus 6 over 2, which is 3. Well, that's a repeat. I already have that, so I don't need that again. So these would be all of my possible rational zeros. Now, that doesn't mean they're zeros. It means that they could possibly be zeros. And when we're looking for somewhere to start to try synthetic division or to try plugging into the polynomial, that's what we use to start with. We start with those possibles. Okay. So I want you to take just a minute and we're going to find all of the zeros. So I'm going to go through the whole process, but I want you to take what we just learned in the last part and find all the possible real zeros that we could get from that. So do the P over Q's and find the possible real zeros. Well, actually, that's the one we just did. So we already have that. Never mind. So we've already got our P over Q's. So I'm just going to rewrite those again. Sorry, I forgot. That's what we just did. So we did all of our P over Q's. We had 1, 1/2, 2, 3, 3/2. I think I can remember that. So plus or minus 1, plus or minus 1/2, plus or minus 2, plus or minus, I thought I could remember, plus or minus 3, plus or minus 3 over 2, plus or minus 6. Now, I can't see what y'all are typing to me. Okay, Victoria, I'll go back. I'm sorry I didn't see that. Y'all can somebody unmute yourself when somebody asks me a question because honestly I can't see it. So you gotta unmute and tell me that you need to ask me a question. I'm sorry, Victoria. On the I mean, if you can do it in your head, I just want to see like your number line and your zeros and then the numbers that you're testing. Do you actually need to show me that you plugged it into the factors? No. So as long as you're showing me that you tested certain numbers and those were your test points, yes, that's all you've got to do. You haven't got to show me like I worked it all out in detail. No, you don't have to do that. You're welcome. If anybody, some people can't unmute themselves. So if you see that anybody is trying to ask me a question, please unmute yourself. And earlier, usually Shelby's the one that unmutes and tells me, but I think I was really short with her a while ago on her question about that question that she had. I didn't mean to be short with you. If it sounded that way, I apologize. Okay. Oh, yours didn't work either. Okay. I just thought maybe I was short with you and I didn't want you to be upset with me. I didn't mean to be short. Sometimes I'm a little abrasive and I don't mean to be. All right. So here we are, P over Q's. We want to take these P over Q's and see if we can find an actual zero. Now there's two ways to do it, and I'm just going to tell you one way is easier than the other. Do you remember when we did just a few slides ago, we did the synthetic division and we got a remainder? That remainder was like the value if we plugged in to the polynomial. So if you do synthetic division and you get a zero for the remainder, that means that that number is actually a zero. So that's one way to do it. But we can use that remainder theorem backwards. If we plug in a number into the polynomial and we get zero, that also means it's a zero of the polynomial. So that's the easy way to do it. It's just to plug in these numbers until we get something that will actually give us a zero. So this is how I do it. I don't use synthetic division until I have to. So I just test these numbers. So first I'm going to test P of 1. I'm going to plug in a 1. Now I'm going to be kind of quick with this. I'm sorry. I'm writing on the wrong screen also. Let me see if I can go back to my other screen. I hope that's not. I didn't mean to write on the screen. Okay. So I'm just going to take these, and actually I always try to start with 1 because if 1 is one of our zeros, then that's a good thing. It's easy to work with. I just have to plug in and see if you do this on your calculator, it's really quick. So I'm going to do it in my head, but you can take your calculator and check me. If somebody has a calculator handy, if you will just plug this in and check it, then in your calculator, you probably can just go in there and edit and change the numbers. That's a really good thing about using a fairly advanced calculator is you can plug in this stuff and then just go in and edit. I'm actually plugging it in my calculator in case I need to. I don't remember how many I have to check. So I get -6 for this. And then, it's good if you have one of these calculators where you can just go back in and highlight and change the numbers. So the next thing I'm going to do is check -1. I got 18 when I plugged in a -1. So that's not a 0 either. So I'm going to skip the 1/2. Now I may have to come back and use the 1/2, but if I don't have to, I'm not going to. So next I'm going to try the 2. So all I'm doing is I'm just highlighting my equation, and I'm just going in and editing. So when I plugged in -2, or when I plugged in 2, I got -6 again. So this can get to be kind of tedious, but if you got a calculator where you can just easily copy your equation and then just plug in. So I plugged in -2 and I got 18 again. All right. Well, this is not good. This is not lots of fun here. So I got to try 3. I forgot about this problem being like this. Sometimes it happens though, so we may as well start with one that's like this. So I'm just trying numbers. I'm not writing all this down and talking you through it. I'm just trying these numbers until I get something that works. Hmm. I'm just going to have to keep going until I find something because I still don't see. I must be why I gave myself another slide. I'm sorry, y'all. I'm still working on this. Are y'all working on it? I'm just beginning to think that there are no real zeros to this equation. Maybe there's an error in it or something because I can't find one. I'm not getting the answer that I'm not getting a zero for any of these numbers that I'm plugging in. I even tried 1/2. I do. I'm teaching a class, so I do have it. No, it's on. No, yes, it is out. Yeah, I'm teaching a class, and I think they're still here. They're not saying anything. I'm trying to do some calculations here. Yeah, they're supposed to be doing them too. All right, guys. I don't know. Have y'all done any of these calculations for me on your calculator? You haven't gotten any either? Okay, so you got P of -2 is equal to 0. Well, let me see what I did wrong then, because I tried that one, so maybe I did something wrong. I bet I did. So you got -2. So let's try that one. 2 times -2 cubed minus 3 times -2 squared minus 11 times -2 plus 6. All right, hopefully that will work. I must have plugged something in wrong on my calculator a while ago because I thought that I tried this one. Yep. -2 gave me 0. So I went through all of those other numbers down here for no reason because I had tried a half, and I think when I plugged it in the calculator, I left off that square. So these numbers I was getting were not right, I don't think. I think I left off that square right there when I plugged it in my calculator and I kept using the same equation. So -2 works. Now, what does that tell us? All right, so that tells us that -2 is actually one of our zeros. So we know one of them. I'm going to use that -2 and I'm going to do synthetic division now and see if I can find the rest of my zeros. So I'm going to bring down the 2, the first number there, and then I'm going to start multiplying. And I already know I'm supposed to get a remainder of 0. So if I don't, that means I did something wrong. So I got the 0, and now I know the rest of my equation. I know one of my factors is going to be x plus 2. Because remember, if x equals -2, then you got to move that over, and it's going to be plus 2 is going to be the factor. So I'm going to have x plus 2, 2x squared minus 7x plus 3. And then I need to factor 2x squared minus 7x plus 3. So I've got to multiply to get 6 and add to get -7. So I'm going to break this down into -6x minus 1x. That's how I factor. I don't know how you factor. It's other ways too. And then factor out 2x, and I have x minus 3. And factor out a -1, and I have x minus 3. So that's going to be 2x minus 1, x minus 3. Yeah, so there's another 0 too. So when I check 3, it should have worked as well. So I got 2x minus 1 and x minus 3. And if I set those equal to 0, I can solve for the other zeros. So I'm going to add 1 to both sides. 2x equals 1. And then if you divide by 2, you get x equals 1/2. Plus 3, plus 3, x equals 3. So really, there's 2 that I checked in my calculator. I just had something wrong with my equation that I plugged in. That's the bad thing about using that equation. So those are our factors: 2x minus 1, x minus 3. You have to set each one of those equal to 0, which we already knew this was -2. So we get -2, x equals -2, x equals 1/2, x equals 3. Those are our actual zeros. And I know that I'm finished because I don't have any other part of a polynomial to go through. So I don't have to do anything else besides just get those. There's no polynomial left. It was a third degree order polynomial. So therefore, there's on the maximum number of zeros I could get would be 3. I think that I will skip that one and let you do that one because I want to do one that's got, this is getting you started on it. So you find your possible zeros, and then actually this slide should be here. So you want to find all of your possible zeros and then use those to plug in to your polynomial until you get a 0. And then you can do synthetic division and finish it. It's a third order, so you should get 3. And I'll go over that one with you next time. I just want to make sure I've got time to do this fourth order. So let's get our P over Q. So remember, the P comes from here. The P comes from the last number, and the Q comes from the first number. So the factors of P are plus or minus 1 and plus or minus 2. Well, I won't, I'll just list the factors 1 and 2. So 1 and 2, and the Q's are just 1. So P over Q is going to be plus or minus 1 over 1, plus or minus 2 over 1. So that's all we have. So basically, those are only 4 that we would have to test. So if I plug in 1, I'll see if I can do this time without making a mistake. At least y'all know that I'm human, huh? So 1 plus 1 is 2, minus 1 is 1, plus 1 is 2, minus 2 is 0. 2 minus 1 is 1, plus 1 is 2, minus 2 is 0. So 1 is a factor. So that's good because that we don't have to keep going through all of this forever. I got one right. Okay, so I know that 1 is one of my zeros. So I'm going to use synthetic division to try to find some more zeros. So my multiplier is 1. I brought down 1, 1, negative 1, 1, and negative 2. So I'm going to multiply by 1, bring it over, add, multiply by 1, bring it over here to the next slot and add, multiply by 1, add, multiply by 1, add, and I got a 0. And I knew I should have gotten a 0. So now I'm going to go x cubed plus 2x plus 1x plus 2. That's a squared. So I know that x equals 1 is one of my zeros. So here is a 4-term third-degree polynomial. And I'm looking at it and I see the possibility that this might factor by grouping. So here's the thing. Either I got to start all over and find another 0 besides the 1, or I need to go ahead and just do this group factor by grouping. So when I've got 4 terms, remember you can try, anytime you have 4 terms, you can try to factor by grouping. So before I start going with those trying those P over Q's again in this one, I'm going to try to factor this by grouping. So my GCF is x squared. So that leaves me x plus 2. And this one doesn't have 1, so I just factor out a 1. So that gives me x plus 2, x squared plus 1, because that was positive. And if I set those equal to 0, I can solve for the rest of my zeros. So I have x plus 2 equals 0. So x equals negative 2. And you can check that was one of the possible zeros. And then I get x squared plus 1 equals 0. So I need to come over here. X squared plus 1 equals 0. If I subtract 1, I get x squared equals negative 1. And if I use the square root property, and some of you missed this before because you didn't put your plus or minus right there. It is a plus or minus when you use the square root property. And the square root of negative 1 is I. So x equals positive I, negative I. So we can get imaginary zeros. And since that's a fourth degree polynomial, I can have up to four zeros. So those are my 4 zeros. I should have 4 zeros, even if 2 of them are imaginary. Now, what that tells us about the graph is basically at -2 and 1, our polynomial is going to cross the x-axis. Now, there may be some other zeros throughout this graph, but it's never going to cross the x-axis again. But there are going to be imaginary zeros. Now, in some of your later math classes, if you take some higher order algebra type classes, you might start graphing these and using those zeros for graphs. But for this class and for the purpose of calculus, this is as much as you need to know about finding zeros. You just need to be able to have some techniques to find some zeros if you don't have access to a calculator. And I just want to tell you that most four-year universities don't allow you to use calculators in calculus. And so sometimes I feel that in community college that we're doing you a disservice by letting you use a calculator. So if you don't have to use one, only use it when you really need to, because some calculus classes, most four-year calculus classes, like Alabama, Auburn, and South Alabama, for 3, I know they don't let you use a calculator in calculus. See what else. There's lots of things in chapter 3. Test review problems, those are going to be in your textbook from chapter 2. There's some more review and solutions. That should be like a practice test. And then here's all kind of guided notes and things from 3.1, 3.2, and 3.6. So here's lots of practice problems. Those are going to be all of your review problems. And then this chapter 2 and 3 test review solutions, it posts the solutions for all of these things, plus the ones that were from your textbook. Now, I'm not going to post that yet because I want you to do your graphs. I want you to do your work before you see the solutions. So you should be practicing on these. You don't have to do every single one of them, but you should take them and practice as much as you need to practice from them. And then blank graphs that you can print to use for your review problems and for your test. So your next test will be in Canvas. Today is Tuesday. We'll finish the chapter Thursday, review Tuesday. So your test will be next Thursday. And it's on the syllabus too, at the under the syllabus, under the course outline. So do y'all have any questions? Questions about any of that? There's all kind of resources for you to practice. So you don't have any excuse not to be practiced up for this test. But it probably is the hardest test because there's a lot of material to cover. So don't wait till the night before and think you're going to review. That's going to not going to work out real well for you if you wait until, yes, you can come on campus. It'll be a Canvas test on Lockdown Browser and Respondus Monitor, but there will also be the opportunity to come to campus. Now, let me say this while I've got y'all on here. When you do your environment review, if you're taking the online test, your instructions say, show me that you are putting your cell phone 6 feet away. I've watched the videos and I haven't said anything so far. But if you're not showing me that you're putting that phone away this time and you don't follow the instructions and show me your workspace, I'm going to give you a 0 and I'm not even going to blink and I'm not even going to email you and tell you why. You just got to know if you got a 0 on your test put in, it was because you did not follow instructions for the environment review. When you do your environment review, I want to see the whole room. I want to see your desktop or your table or your bed or wherever you're taking your test. I want to see the whole area. And I want to see you put your phone 6 feet away. Like you have got to show me on your webcam that you're putting your phone away. If you don't like those instructions, you can come to campus and take your test. If you don't like those instructions, you cannot do them and you can get a 0. But I didn't have time, just to be honest. And I'm going to send out a nasty email about it. But I didn't have time to give all of you 0s and explain myself. But I'm going to explain myself beforehand and I'm just going to put the 0s in. I hope that's clear to everybody that I mean what I say on that environment review. If you don't follow those instructions, I'm going to put a 0 in and I'm not going to blink and I'm going to get back up because I'm going to have those videos where you didn't follow your instructions. All right. So probably be easier if you want to come to campus to just come to campus and take the test. Hopefully we won't have another hurricane between now and then. Maybe it will not come here this time. I hate to wish it on someone else, but we had our hurricane. All right, any questions before I go? I don't mean to sound so blunt today, but I guess today's a blunt day for me. But that's just when I looked at those videos I didn't have time because I have like 30 people in this class, 30 people in another class, and I didn't have time to deal with explaining myself. So I'm going to explain beforehand and just tell you there will be no explanation for the zero. If you don't follow instructions, don't email and ask me how you got zero. You'll know. If you didn't follow instructions, you get zero. Okay? That's all.